The Y, the A, the R, and the T all stand for the same thing, increasing and decreasing, positive and negative. Today's questions are all going to be old Regents questions. They actually ask about exponential growth and decay a lot, but they're actually pretty easy. So we're going to look at these. These first four are short answer ones, and then the rest are multiple choice that we will look at. So if we look at these first four, it says Dylan invested $600 into a savings account at a 1.6% annual interest rate. He made no deposits or withdrawals for 2 years. The interest was compounded annually. Find to the nearest cent, so that's going to be 2 decimals, the balance of the account after 2 years. So you can still list out your A, R, and your T here. Anytime you're putting money in a bank account, investing money in a savings account, it doesn't say it in here, but your money is growing. So we're going to use our Y equals A times 1 plus R to the T. The Regents likes to make you assume things sometimes. So our initial amount that we're putting in the bank is $600. Our rate is 1.6%. Don't get tricked and think that that is our decimal just because there's a decimal in it. That is a percent because it has the percent symbol. So we still need to move our decimal over, so it's 0.016. And then our time is 2 years. So Y equals, our A is 600, our R is 0.016, and our time is 2. So just like before, I'm going to type that all directly in my calculator. So 600, 1 plus 0.016 raised to the 2, and hit enter. So $619.35. So $619.35 is the amount in the bank account after 2 years. So he only made $19.35 in 2 years. Number 2 doesn't actually ask you to find, you don't have to solve it. It says Rhonda deposited $3,000 in the account in the Merrick National Bank, earning 4.2% interest compounded annually. She made no deposits or withdrawals. Write an equation that can be used to find B, her account balance after T years. So they're asking you to change Y to B here, so we're going to say B equals, and they're still using T for their time. But notice, they're not asking you in a certain time, they're just asking you to write the equation, not solve it like we have been. So the initial amount that we're putting in the bank is $3,000. 4.2%. Again, remember, be careful when we move this over. It's 0.042. And our time is just T still. So we're going to say B equals 3,000 times 1 plus 0.042 raised to the T. I could have written out my equation to start. I should have, but I forgot to. But it's not wrong if you don't. I just like if you guys write your initial equation so that way you know what you're substituting in for. 3 and 4 ask you to do, not 4 as much, but 3 asks you to do a little bit of extra work along with your finding your answer. So it says a car was purchased for $25,000. Research shows that the car has an average yearly depreciation rate of 18.5%. Create a function that will determine the value V of t, so again they're changing your Y to V of t, of the car t years after it was purchased. So first they just want us to write our function like we did in number 2. Then it says determine to the nearest cent how much the car will depreciate from year 3 to year 4. So we want to find year 3 and find year 4, and we want to know the difference between those 2 years, so we're going to subtract. So first we're going to do A, R, and T. So the initial amount of the car is $25,000. Our rate is 18.5%. Remember 1, 2, so again we don't need to add any zeros to this one. And our time is going to be 3 years. Then we're going to do one with 4 years. So we're going to do 2 different problems. First, I need to write out my formula. So V of t equals 25,000 is my A value, 1 plus 0.185 raised to the t. You have to show that because they want you to create the function with v of t and t in it. Now I'm going to tell them that I'm finding v of 3 first because I'm substituting 3 in for my t value. So 25,000, 1 plus 0.185 raised to the 3. So we're going to tell them v of 3 equals, I'm going to go in here, 25,000, 1 plus 0.185 raised to the 3. So I get that. So when it's 3 years, it's still worth, oops, I made a mistake in my problem. It's depreciation, and that's why I noticed it. I was like, wait a minute, my car value didn't go down. Why did it go up? It's depreciation, so these should have been subtraction signs. So minus and minus. So let's try this again. 25,000, 1 minus 0.185 raised to the 3. That makes more sense. So the car is worth $13,533.58 after 3 years. And now we're going to find v of 4. So we're still going to do 25,000, 1 minus 0.185, and raise it to the 4th. And now we're going to type that one in our calculator. So 25,000, 1 minus 0.185 raised to the 4th. And after 4 years, the car is worth $11,029.87. So to find the difference between year 3 and year 4, we need to do 13,533.58 minus 11,029.87. I'm going to type them in my calculator. Minus 11,029.87. So we get $2,503.71. Make sure you definitely box your answer in here because of all the different work that you have going on in the problem. Notice I caught my mistake right away because I knew in my head that that should be going down, and when I read that amount of 40-something thousand, I was like, wait a minute, my car value shouldn't be going up. So you can always use those little ways to check yourself. Number 4, Marilyn collects old dolls. She purchases a doll for $450. Research shows this doll's value will increase by 2.5% each year. Write an equation to determine the value V of the doll after T years after purchase. Assuming the doll's rate of appreciation remains the same, will the doll's value be doubled in 20 years? So again, like I said, a little different. So first, again, they want us to write our equation. So A, R, and T. We're starting with $450. Our rate is 2.5%. So I'm going to move my decimal over 2 times. So 0.025. And I'm going to leave T blank for right now. So I'm going to write my equation. V equals 450, 1 plus, because we are increasing this time, 0.025, and we're just raising it to the T, because it just said write the equation for T years. Then they want to know if after 20 years, so my time is going to be 20, if the doll's value doubles. So 450, 1 plus 0.025 raised to the 20. And I'm going to type that in my calculator. So 450, 1 plus 0.025 raised to the 20. And I get V is equal to $737.38. What would the value of the doll have to be for it to double in 20 years? Well, if the initial amount was 450 times 2 for it to double, it would have to be 0, 10, 4 times 2 is 8, plus 1 is 9. It would need to be $900. Did the doll's value double? And we can say no. And justifying your reasoning is this work right here. Let's look at some multiple choice problems. So it says, Anne invested $1,000 into an account with a 1.3% annual interest rate. She made no deposits or withdrawals for 2 years. If the interest was compounded annually, which equation represents the balance in the account after 2 years? So what's nice about these multiple choice problems is you can narrow out ones that don't make sense. So first of all, when we're talking about money in a savings account, we said the value goes up. So I'm going to cross out choice 1 and 3 because they're both minus signs. And then the other thing the Regents always tries to do is trick you with this R value. Remember, my R is 1.3%, but I need to move my decimal over 2 spots. So it's 0.013. They always put the actual percent in there to try and trick you. So it can't be choice 4, it has to be choice 2. Number 6, same thing. It says, Crystal was given $3,000 when she turned 2 years old. Her parents invested it at a 2% interest rate compounded annually. No deposits or withdrawals were made. Which expression can be used to determine how much money Crystal had the account when she turned 18? So this one has 2 little tricks to it. First of all, if it's money in a bank account, we can get rid of choice 2 and 4 because they're minus signs. They didn't do anything with the percent this time. They did all the percents the same, but notice 2 of the years they have 16 and 2 of the years they have 18. A lot of kids want to pick 18 because it's when she turned 18, but you have to pay attention to the fact that they didn't start the account till she was 2 years old. So 18 minus 2, only 16 years have passed, so the time is actually 16. Number 9, Jill invests $400 in a savings bond. The value of the bond, V of X, in hundreds of dollars after X years is illustrated in the table below. Which equation and statement illustrates the approximate value of the bond in hundreds of dollars over time in years? So notice what is happening every year. Her amount of money that she has goes up. So obviously it's growing. If we look at our multiple choice, 2 of them say grow, 2 of them say decays. So I can get rid of the decays. Remember, we have 2 different options with our formulas. 1 plus r to the t and 1 minus r to the t. If I do 1 minus r, isn't my number going to be smaller than 1? That number will always be smaller than 1, obviously, if we're subtracting from 1. If we're adding to 1, this number is always going to be bigger than 1. Well, we already said that it's growing. If it's growing, we're going to use this formula. If it's decaying, we're going to use this formula. So if it's growing, we want our number in the parenthesis to be bigger than 1 when we add them together. So it has to be this one. This one wouldn't make sense. Number 10. Mark bought a new laptop for $1,250. He keeps track of the value of the laptop over the next 3 years as shown in the table below. Which function can be used to determine the value of the laptop X years after purchased? So remember, he bought it for $1,250. Remember, our formula is A1. This time we're going down, so minus r to the t. Move that over so you can see what I wrote. Our A is our initial value. Be careful, 1,000 isn't our initial value. That's 1 year after purchase. 1,250 is our initial value. So we can get rid of 1 and 2. It's really nice with multiple choice to cross some out. Then, just like we did up here, we have to look in that parenthesis because that's the only difference. This parenthesis is bigger than 1. That means it's growing. The value of our computer isn't growing, it's going down. So it can't be bigger than 1 in parentheses. It has to be less than 1. The table below shows the temperature T of M of a cup of hot chocolate that is allowed to chill over several minutes. Which expression best fits the data for T of M? So again, notice our value each time is going down. So if we look at our choices, all of them have an A value of 150, which is good. But choice 1 and 3 are less than 1. 2 and 4 are bigger than 1. Bigger than 1, we're growing. Smaller than 1, we're going down. Since we're going down, I don't want the ones that are bigger than 1. And we never deal with exponents with subtraction. We just deal with our M or our minutes. So it wouldn't be choice 3. It has to be choice 1.